Welcome to this video. In this video I'm going to show you how you can create vector images in Pygame Zero. This is part of the book that I wrote, Beginning Game Programming with Pygame Zero. In this video I'm going to show you how to create a tank shape for a military combat tank as part of a game called Pygame Zero. I'm not going to create the full game here, although I will demonstrate it afterwards, but just show you about creating the which is using vector images. So before I get started, just to explain what a vector image is, it's that instead of the image being created like a photo, which is held as lots of different dots of color, the image is created up using shapes. And these could be basic shapes like rectangles, circles, ellipses, but also more complicated shapes. So it could include polygons so that you can create virtually any shape you want. In this, we'll be building this basic tank, which you can see here. I've already worked out the dimensions of this, which you can see dotted around the image. This is scaled from the one that's actually used in the game, which I'll show you afterwards to make it clearer and easier to see while we're creating the game. So with all these, probably the best editor for getting started with Pygame Zero is the Mu editor. This is included as default now on the standard Raspberry Pi Raspbian image, which is what I'm running here. And you need to be running in mode Pygame Zero, which you can see from here in Pygame Zero mode. If it's the first time you run it, then it prompts you, or you can change using the mode button. And you see we've got a blank screen with just a comment here, which we can just get rid of. So with any Pygame Zero file, I usually start with putting the dimensions of the screen. And it's just in capitals, width 800 by 600 screen. Now you don't actually use at all because they're the defaults, but I find it's useful to include those, and if you want to change the size of your game window, then you can do so. Then the next function I'm going to create is the draw function. Now this is a standard part of Pygame Zero. If you create a draw function in your Python file, then this will be called by the Pygame Zero libraries roughly every 60 times per second. So will regularly run, but you can't guarantee the timing. There's ways you can check on the timing, but that's beyond what I'm going to show you here. I mean, for this purposes, it doesn't really matter. We just need to know that it's updated regularly. Now I'm going to start by setting position for the tank to start. This is bottom left hand corner of the slightly up, very bottom left of the image you saw earlier. And I'm going to start with this at position 50 on the x-axis, and on the y-axis it's going to be position 400. So as you expect in Cartesian coordinates, the x position starts at 0 on the left hand side and moves upwards. The y position starts at 0 on the top and becomes more positive as you go downwards, which is flipped from Cartesian coordinates. But basically remember that the top left hand corner is 0, 0, and then the bottom right is whatever you set your width and height, and it counts in that direction. I'm going to set the color tank as well. I'm going to create this as a variable using green and blue, 216, 216 for red and green, and 153 for the blue value. And then the first thing I'm going to draw is body or the hull of the tank. I'm going to do this mainly because it's simpler to demonstrate, and then the others get a bit more complicated. So the starting position is going to be the top left-hand position, which in this case is 80. So the X is 60 pixels in from the left, and the height is 80 pixels higher. As this is in, as the numbering of the y-axis goes downwards, that's going to be -8. And to create this, we need to create what's known as a rect object. So we call it the hull rect. And this is going to define a rectangle, but it's not going to draw anything at this stage. This is just creating an object that's going to explain the dimensions of this. So we're going to the X position, which is the starting position, plus 60. And then the Y position, minus 8. Missed a bracket there, so there should be brackets at the beginning. The first bracket is for the rect method, and then the second one is because this is a tuple of two values, one side for the X value, one side for the Y value. Then after this, we're going to give the dimensions relative to this starting position. So in this case, it's going to be 120 along the X and 40 on the Y, and this is going to go downwards, so it is a positive number. And this created the rect object, and this just describes what the rectangle will look like. It doesn't actually create anything, as I said. So to draw the rectangle, we use screen.draw rect, which is a standard Pygame Zero object, which will give us a filled rectangle. The hull rect as the rectangle that defines it, and then the color. And if we click, first we'll save this now. We'll call this tank demo. PY. Now if we run this, then hopefully we have a rectangle. And there we go. This is assuming that the base of the tank here, it's going to be offset to the left, and there should be the tracks would be here, and then the turret. So all we've done so far is draw the rectangle. Now that's all you need to do to use the basic shapes of Pygame Zero. However, it is limited in what shapes you can use. The next thing I'd like to draw is the tank tracks, and that's a polygon. Now, Pygame Zero doesn't support the polygon. However, it allows you to use the other functions that are available, the other methods that are available in the native Pygame, which is what Pygame Zero is based on. And to do that, you need to import Pygame first. Oops. Pygame. And then when we call it, we have to pass the screen. Instead of using the screen here as Pygame Zero uses, we have to pass it the screen.surface. I'll show that in a minute. First of all, let's put it in here. We'll start by defining the coordinates of each of the points of the polygon. I can call this a variable tank positions, which is going to be the rectangle. Now, normally in Python, you have to keep everything on the same line. And indented correctly. If you've got an open brace, an open bracket, or in this case the square bracket, then it knows that the next line is going to be part of this collection. So you don't need to put it all on the same line. So we can put it between multiple lines so that we can make it look a bit nicer. We're going to start with the leftmost point, which is the x position plus 20, and then the y position minus 20, so it's a negative number. Then the next point, which is the top left, is x position 40 and y position minus 40. And continue adding these. I'm going in a clockwise direction. And the rightmost one and then the last two across the bottom. And then we just complete the list by closing that. So this is just a list of coordinates. It won't do anything on its own until we create the polygon. So we use Pygame, which is what we've already imported, and draw.polygon. As I say, with the Pygame Zero things, it already knows about the screen. Here we have to pass it the screen.surface, the tank color, and then our list of coordinates. So if we run this, then hopefully we'll have the tank track. Yeah, so here we are. These are the tank tracks underneath the hull of the tank. On the top, I'm going to put an ellipse to give it the turret. Now, again, Pygame Zero doesn't include the ellipse, so we're going to use it straight from the game. And to define an ellipse, we create a rect object, like we did the rectangle. And what it will do is create an ellipse that will fit within that rectangle object, or the rect object. So first, let's define the turret rect. case, it's plus 80. Oops. Y mission minus 100. Now we can use the draw ellipse. He was quite helpful in offering to autocomplete. That's aware of. So I run this, and it's drawn the ellipse. So in this case, um, you can only see the top because the bottom is the same color. Now, on this, it looks really blocky, and but this is designed to be much smaller. When we create a smaller version, it'll look a lot smaller, and it won't look quite as blocky and misshaped as this does. And you'll see that when we get to the final game. But if you wanted to create a more smooth shape, then you just create polygons with more points on it, and you can create curves or whatever shapes you want using the basic polygons. Right, the next thing to add is the gun turret. Now, the gun turret will be created as a polygon, and it's going to be created. Um, it looks like a rectangle, but because it's twisted at an angle, it has to be a polygon. So we have to work out the positions of this, or rather, the computer does. So we're going to create a function that can calculate the positions of the gun turret. Rather than typing these all out, I have already got it saved. So I'm going to just load this code, and I'm going to copy and paste it into my existing file. This is it's a function that gun positions. It's going to take the start position of the turret, and then sorry, the start position of the tank, and then it'll work out the position of the turret, and then an angle that the turret is aimed at, and then it's going to work out the positions and return those as a list of coordinates, which we use using the polygon method from Pygame. So as you can see, it starts with the tank position. I'll just go through some of what it does because it does involve a little bit of maths. So we work out where we want the gun to start in the top left hand corner. In this case, because the tank's going to be pointing towards the right. And we're going to work out the relative angle based on the angle that the gun's pointing at. So we can use a more sensible angle for the gun. Then we're going to convert it to radians from degrees. The math.cosine and math.sine functions work in radians. And then this is the maths to work out the vector, which is the direction of the top line of the barrel. And this is basic trigonometry. It's explained in a bit more in the book, but this should be normal sort of high school maths level. Then something similar to work out the angle towards the barrel. And out. So we've got the vectors, and then we can apply those vectors to the actual start positions and the sizes to work out the actual gun positions that we need. And then this is returned as a list. We've used the math library here, math module. We need to just import that as well. And then we can call our new function draw function. So we're back in the draw function, which is being called by Pygame Zero. So I'm going to call it the positions. Using the calc positions function that I've created. And then using the start position, which is and then the gun angle. I'm going to set 20 degrees, which is the starting point. And this just returns the list of coordinates, like we created manually using the track positions. And so we can feed these to the polygon. Run this now. You can see there's the gun turret coming out of the top of the tank. So that's shown you how you can create these basic shapes and create them into an object, in this case a tank. So this could be put into a function and would then be used to draw the tank in whatever position you want it to be. So this is as much as I'm really going to show as part of this video, but I will show you the completed code. So as I say, it's in my book, which is called Beginning Game Programming with Pygame Zero, and it's published by A Press and by me, Stuart. If you just search for A Press Zero, and hopefully it should be the first result. Take a little while to load. So just while this is doing this, obviously it'd be great if you bought my book and each other. However, can download the source code, which is provided, made freely available, whether you bought the book or not. And I'll show you how to do that. And you can read the source code, and there are comments in it. You should be able to work out from this video how this works. Okay, my internet was a bit slow there, so it's loaded now. Click on the book, the link to the book. The page is loading now. If you go into the book page, there's a link to the source. I'll also include a link to this page from the description underneath the video. If you click on the source code, then you're going to go to GitHub, where the source code is. And then from GitHub, you can either download a zip file or you can clone or you can download the individual files. So my GitHub page is now loaded. You can click on. So you can access the individual files. Go to chapter 7 and find those files, or you clone the whole GitHub repository, or I'm going to use the download zip option, which is going to download as a zip file. And just clicked on it to open it in the archive tool, chapter 7. So I only need the one file here. These are various stages in the development. The tank game is the completed file, and that's what I'm going to save. And I'm going to extract this to the new code folder. And because this is all created using vector images, there's no other files to download. Literally, it's just the one file. Just load into here, and it's tank game. This is the complete game, so I'm going to show you how it works. Very quickly look through the source code. If you want to do the source code, then you can go through, work out what's happening. It starts off by creating a lot of variables. These are the constants for the colors, the initial variable for which angle each of the tanks guns are pointing at, the tank positions. Now they're actually at 0, 0. They'll be auto-generated as part of the setup. The draw tank function, you'll see it's very similar to the code we've just been using. The offset values are smaller. These are going to be smaller tanks. Draw shell, draw the shell that's being fired between the tanks. Calculate gun position, very similar to the one created. The main bit, it handles the tank on the left and the tank on the right. Just add a little bit more code there. Draw function includes some text for showing text to the user about the state of the game and tracking. And then the update is going to provide the handling of the keyboard, which is how it's going to be used to control moving the turrets up and down and the power. Updates the shell, it fires across, detects a hit. Here's the keyboard handling. And this is the setup, which is called initially to work out random positions for. It also creates a random background, which you'll see when we start to play the game. And finally, the last entry is the setup, which calls this function when it's first started. You can see it's created a background, created the sky, just a plain color for the the sky, and then the background is drawn as a polygon over the top. It's work created randomly. This is our tank, and as you can see, it's a smaller version of the that we created in this video, and so it looks a little bit more realistic as such as, whereas when it's blown up and zoomed in, it starts to look a bit more blocky. So by adjusting using the up and down arrows moves the turret, and left and right will adjust the amount. I'm going to just fire this ridiculously high. Hopefully this will miss. Yeah. So that it runs quite slowly. That's a deliberate thing. You can change the view of the speed, the velocity of the shell, so that it gets a bit more realistic. But it's set to demonstrate how it's working and to show the arc that the shell will take. So if we run it from here, as you can see, this is a lower power, so this is running much more slowly. So this is a two-player game. So one person would take the left tank, and the second player would take the right tank, and it just uses the same keyboard, so it's just a case of swapping over. You could, of course, modify it and either you could even create it as a network game if you want, or you can set different keys, use control as well. So one of the things in the book is I do mention use a simple controller. You can see we've scored a hit this time. Game over, play 2 wins. So that's how you play the game. I'll just run it again and just note that the position of these tanks and the texture of the background. If I again, you'll see that the tanks position and the is looking very different. This is because this is all using random variables, random numbers that I generate as a demonstration as well of how you can create a random settings to include. So I'm going to leave it there for the video. I hope you found that interesting. It's just a simple introduction to creating vector images within Pygame Zero. See a book, which it'd be great if you decide to buy. If not, then feel through the source and read and figure out how the game works that way. I'm going to create probably a couple more videos related to games in the book. So if you'd like to know when these are out, please subscribe to my channel, Pygame Tutor, and if you click the bell icon, then it'll let you know when I create the next video. And thanks for watching.